So my name is Owil James, as your professor has already introduced. I work for Rockflow Dynamics, and today, basically, we'll be introducing you to To Tnavigator. To Tnavigator is a software application that is developed, that's being developed by Rockflow Dynamics. Rockflow Dynamics was incorporated in 2005, and it has been there for more than 15 years. So the software also started development in 2005. So we have 15 years of experience developing this software. The headquarters is located in Moscow, and it's quite a bit centralized system where all the development is taking place in the headquarters. But in addition to that, we have offices around the world. We have 34 offices in 30 countries. So I will show you the map where we are. Here in Nigeria also, we have an office in Lagos. We have more than 300 now, more than 300 commercial clients in 43 countries. We have more than, so this, since the end of last year till this year, we've recruited additional developers. So we have about 150 developers in our headquarters in Moscow office developing the software. As a result of that, we have 4 major updates annually. So intermittently, we also have some updates between 2 major updates, but we have 4 releases annually. So this makes us kind of, listen to positions us in a situation in a situation whereby we listen to our clients and then we incorporate their problems back into the tool. So that's why you'll see very quickly that the tool is quite interactive. So it's really easy to use. In addition to these developers, we have about 100 now, technical support engineers, so both geologists and reservoir engineers who are located in all of these offices, okay? So this is just a few words about Rockflow Dynamics. I don't know, do we have, so can we start now or should I wait till it's 9:30?
James, I think you should just go ahead.
Okay, thank you.
Yeah.
So, so a very quick one, what are the key advantages of this tool in comparison to the competition we have in the markets? One of the main advantages is in the integration. So this tool is fully integrated. What I mean by that is that it integrates both the subsurface modeling and the surface network system modeling in a fully coupled and fully implicit manner. So that is for each time step, it performs the calculation from the subsurface, both subsurface and surface network system. So this means that there's no time wasted in data transfer from one application to the other, and you expect to have a better performance in your predictions. Also, so for this integration, of course, it means that we have several modules. Okay, so we have the preprocessors, which allow you to prepare your model. And then we also have the simulation engines. So we have several modules. You will see later on when I open the application itself, but we have a module that allows you for your static modeling. We have a module for your dynamic modeling, and then we have a module for the network system models. In addition to that, we have a module that allows you to model your fluid, so your PVT modeling, and a module that allows you to prepare your flow performance tables. We have unique tools for assisted history matching and assisted history matching, uncertainty analysis, and production optimization. So this is one of the main advantages of To Tnavigator. Another key advantage of To Tnavigator, perhaps that's what most of whoever has heard about To Tnavigator, that's one of the first things you will hear, is that it's quite fast. And the reason is that it takes advantage of the modern computing architecture. So in terms of parallelization, so it uses all the cores you have in your system, your machine. So previously, a few years ago, let's say 20 years ago, thereabout, you had systems that had they all had one core per PC, CPU. Yes. So here started from 2003 or 2004 thereabouts, Intel and Co started developing multi-core processors. So you have more powerful machines. To Tnavigator codes have been written in parallel. As such, this takes advantage of these multi-core processing units. So you can either use so by default, it's using the maximum number of cores you have in your machine. Maybe a PC, a workstation, and run it on cluster. So this is another thing. It's multi-platform application. And because of this, To Tnavigator is quite fast. So if you have the more cores you have, the faster it is. So it is scalable. Okay, and then it's also built such that it's very intuitive and it gives you a very interactive graphical user interface. Another key thing is that it's very easy to run models that have been built in or that have been run in other applications. This is not so common, but so we read E1, E3 syntaxes, we read IMEX, GEM, so CMG suits syntaxes. You don't need to do anything. We read a lot of their keywords. Although sometimes in very special cases, you may have few keywords, very few keywords that may be missing. And then in that case, all you need to do is report it. And because we have several updates per year, this will be easily taken into account. And then you'll be surprised to see it in the following subsequent updates. We also have advanced features. We support unstructured grids. We have some advanced user arithmetics that can allow you to create your own property, and also visualize it and maybe add it and use it for analysis of your reservoir performance. Interestingly, you also can also add some Python codes for those of you who like little bit of programming. So you can write some scripts, Python scripts, and this will be executed. And this will be executed and then you can visualize the properties you have defined or you want to see. We also have 3D streamlines. This is quite interesting and important. We have auto split and mesh. So here, smart pricing policy, anyways, we're not selling it to you. So, but this is just to bear in mind that we are not pricing, where you're not paying for additional cores you have in your machine, CPU or GPU. Okay. So To Tnavigator can also be run in only GPU mode, as a matter of fact. You can have a hybrid of CPU and GPU, so where some minor calculations are being carried out in using the GPU, and then some more complex operations will be conducted using the CPU. Okay, so you have all these possibilities. It's just to find out which one suits you best. But in this case, since I understand that a lot of us here are students, it means that mainly for educational purposes, you are not running too complex models. The models you'll be running mainly will be maybe small and also not so time consuming, so that you can be able to do a lot of things and see a whole lot of things in a short while. So that's it. The rest following slides are all what I've explained. This is so To Tnavigator is actually known for simulation, but more to that, To Tnavigator has, as I told you, it's fully integrated. So you have this workflow. Previously, in previous versions, To Tnavigator for the seismic interpretation, it's so because this was relatively new. This is relatively new. So The seismic interpretation previously was not really an interpretation tool, but now the seismic aspects, you can use it for full seismic interpretation, okay, make complex seismic interpretations. And then in this same suite, you can perform data correlation, so well-to-well correlation, etc. You can create a structural model, you can build your petrophysical model, and then, of course, when you have everything, you have your hydrocarbon in place. And then in To Tnavigator, you can perform PVT modeling. So from your PVT experiments, your laboratory experiments, your CVD, your CME, etc., you can match all those experiments with diffusional states and export either as black oil or as compositional models and use in your simulation. Okay, and using your simulation, yeah, right here. And then you can integrate, so you can either stop your simulation, you know how it is, either you control your well with some BHP or THP, so meaning that you have to specify your VLPs, so vertical lift course. So here actually there is something missing, so we have the VLP tool also, okay, and then you can integrate that with your surface network system and perform the full simulation from subsurface to surface. You can also perform, as I said, the stream machine or uncertainty analysis or production optimization. Okay. So To Tnavigator offers you, it's a single executable that allows you to do all of these things. So this is it. We are here. So this is just a map of our clients, existing clients. I won't spend time on that. We also provide software donation to more than 80 universities around the world. Here are examples. So Unilag is just coming in. So this is it. For today's session, I will be introducing you to the To Tnavigator simulation graphical user interface. Okay, so the content mainly, first of all, we'll have a quick, maybe not so quick, I don't know, we'll see how it goes because you'll see the interface. So I'll introduce you to this interface, and then following, we'll run simulation, of course, and we'll analyze the simulation results and the history machine quality. I don't think we'll be able to get to the prediction at any time. We stop at, so we have to stop at maybe 10:45. So we'll see how it goes, okay? And in any case, I'm here in Lagos, so not far from you. So that's it. Now let's see what we're talking about, enough of all of this slides. So, this is my To Tnavigator, okay? Application. It's just around, you can see it's around 3. So just 878 megabytes. So it's quite small, relatively small. This is the main To Tnavigator graphical user interface, GUI. And on top, we have the main menu. I won't spend so much time on here, but you can take your time, okay, just to go through it and see what you can do. So this is where you can open a project, but you don't really need to do much with this. Interestingly, is the settings option here. In settings, you can, To Navigator exists in different languages. You can see them in English, and so of course, in our case, you don't need that. But you can also change this theme to black theme. Okay, what you see right here, you can toggle this to change it. So depending on what you want, all right, you can go white or you can come down. So for this purpose, let's use the dark one so that you can see the mouse clearly. Okay. So below, sorry, this is obstructing. So here I told you that To Navigator by default takes advantage of your maximum number of cores you have in your machine. So it's written in parallel. So here is what you see in my machine. I have 4 cores and maximum system threads of 8. By default, this is what it's using. You have the possibility of selecting maybe 4 cores or 8 cores. So if you run simulation using 1 core, 2 cores, okay, the speed of your simulation will not be the same, right? So it's scalable. The higher you for me, here I have 4 cores, but in my office I have 64 cores. So you can imagine, and 128 threads, of course. You can imagine if I run simulation here for a given model might take me, there are some models that take me here around 8 hours or even uh, 12 hours. But if I run it on my machine in the office, sometimes it's just 30 minutes or 1 hour. Okay, so it's highly scalable. You also have the possibility of using a GPU, as I told you. You can select that, okay, and then configure it right here. Then below, we have all the modules we have in To Navigator. On the left, right here, we have all the preprocessors, so all the designer modules. So this is for your static modeling, your dynamic modeling. Okay, so stated there, PVT designer for your fluid modeling, thermodynamic modeling, and well designer for your modeling. And then network designer for surface facility modeling or surface network systems. On the right here, we have simulation engines. So this here we have the black oil simulation engine, compositional and thermal simulation engines. So this model here is the case where you have already run the simulation, then you can just visualize it. So for example, in your company, you have a single license of black oil simulation. If someone else is using this model, you can actually visualize your results that you've already run previously using this. That's if you have additional graphical user interface like this. We have the assisted history machine and uncertainty module, which is a very powerful tool as well for creating new experiments, okay, for assisted history machine and also uncertainty and optimization. So here we have for batch job creations, you don't really need that, and then for cluster system access. Then we have our manuals as well, not least. It's very important. So you open here the manual, you have all the manual for all the designers and the simulation engines. So you can go in there and get some useful things here, okay, etc. So whenever you need it. So so let's run this. So we are going to work with a black oil model. And let me quickly run you through where's this folder. So this is the data file. This is the folder, and this is the data file we want to run. I won't spend time on this, but perhaps for some of you it may be familiar, okay? I won't spend time on that. So here, as I told you, it accepts models run already or models existing in other formats. Okay, TMG suits E100, E300 formats. Okay, so there are these possibilities to open a model. If you use open, okay, you in this case you accept the default settings of To Navigator for opening a model. If you use openers, you have the possibility of selecting certain things. For example, so here you have to navigate to the folder where you have your model. In our case, it's right here in Unilab. So here, okay, and then you select this. We'll come back to that. Okay, yeah, so that's what we have already. Oh, no. Okay, so let's select this. Here you can select, but by default, To Tnavigator can automatically detect what type of model you have. So you see the black oil thermal model, you can detect that. So set it auto. Here also you can set the number of calls as we saw previously. And then you can also decide to select which step to write model open. Okay, so we'll do that. And then you also have the possibility to dump some results, some binary results in a specific folder of interest. Okay, so well, let's say, okay, we have already gone to our folder, our data file. So we want to open the model here. Here, there is also a third one, recent. That recent is, it shows you the folder of all the recent models you've run. So in that case, you don't have to go navigate to the folder quickly. You can just select the previously opened model. Here I have this window that pops up telling me to select the period. Okay, I want to record. So the period I want to record the results, the properties, the 3D and 2D properties. So this is what the dates you have in your schedule already. For those of you also, if you already know about the format, the data structure of simulation model, then this is the date you have in the schedule section. Okay. Please don't hesitate to ask me questions. You can interrupt the discussion, right? It should be an interactive discussion. So this is what you have. You can just say next. So you can decide to select maybe, for example, in some cases you have a very big, large model, okay? And this may consume a lot of memory in your hard drive and so on when you record in all the dates. So you may selectively decide to report the properties you want to visualize, your 3D properties at those dates. Okay, so maybe first and last date, etc. etc. So next, the results. So similarly, so we leave everything at default to keep everything. It's a small model we're looking at. This is fine. So let's say done. And now what To Tnavigator has done is that it has initialized the model. This window you have right here is what we call our simulation graphical user interface. So simulation GUI. So remember that this is a case where you already have an existing model in maybe an existing To Tnavigator model or models in other syntaxes. But you can also create a model from scratch using all our preprocessors. So you create a geological model, you bring it. So it's actually the same interface. So you continue modeling and then etc. etc. So this is the window we have, our main, our simulation graphical user interface. Okay. Right here at the top, we have main menu, which we are quite familiar with by now. You can see different options here. I won't go into through all of them because we don't have much time, but you can go and see. So sometimes, okay, you may have a problem. If you have a problem and you decide to send me your model, okay, so I check your model and know maybe what your problem is. What I will advise you do is you create a zip of this model. So when you select create a zip, okay, you select the path where you want to create it. It will, provided you've already run this simulation, all right, I will be able to run it without wasting time. Sometimes I receive models where I have to go inside and maybe try to remodify the direction of the input files. I don't know. So in that case, just use the zip here, okay, and I will be able to run it on the fly without wasting time. So I can help you better in that case. So there are other options, okay, as you move on, you discover more things. So that's the main window, and then we have the top menu toolbar here. This top menu toolbar have so we have some unique tools, and it also allows you to interactively to interact with your simulation. So this is a tool that allows you to split a model. So split and merge, that's what we call it. This is a tool. So if you click on this, it takes you to the assisted history matching module, which you saw previously. which you saw just, anyways, let me know which time. So, and then this cube takes you to the model designer module, the preprocessor. Okay, so it converts this model and takes it to the preprocessor, and then you can continue working. You can import some new things, maybe some geologic features like faults and so on. You can bring those objects back into your model and then continue working. All right. One very important thing I forgot to mention here in the top, in the main menu here is these files. So this takes you straight to the folder. So you can go to the model folder, you can recognize this. Previously, we did not have this folder. This is a new one that has just been created. So this contains all the results. So far, we've not run any simulation. So there shouldn't be results here. Okay. But yeah, you have all the initial properties and so on. Okay, but this is where you have all your results. Okay, you can close this. And so you have your data file as well. Or from here directly, you can always open your data file. This is the data file we are running. So this is a typical E100, so black oil model. And these are the keywords. If you are using, if you've used E1 before, you should see the main sections, the run spec, the grid. Where's the grid? So the run spec, the grid, the edits, the props, where you have your properties, all these are included and so on. Okay, so you have your data file with all the keywords. This is E100 model, it's not, okay. So it gives you easy access, and you can always also open the other, maybe the grid, the edit, the props, and visualize what you have inside that file. So you can see all the keywords, the PVTO, the PVTW, to describe the fluid properties, the black oil properties of oil, water, and gas. So here you have pressure, density of oil, density of water, density, so yeah, water. So formation, so this is for water, yeah, sorry, so PVTW, formation volume factor for water, and the compressibility, etc. So you have all of this in the data file, right? Moving forward, so this is we've looked at the main window, and then here, very key important tools. If you want to run simulation, this button, red button here, means run simulation. So we click on this, for example, you see we have a time slider here that will start to move. So you see simulation starts running, and this time slider starts moving. But then let me just pause. So these tools here, so you have the run simulation. You can pause your simulation. You can see simulation is paused at this time step. So this is the schedule once again, what the dates you have in your schedule section. All right. So once again, if you go back to the data structure, this is your schedule section. You can come here to see those dates. You see a date here. You see this keyword on his dates, 18th of June, and so on. These are the dates you have right here, and then it moves according to this time slider. Interestingly, you can also see on these dates that here we have, you see the colors here are different from the colors here, simply because we have results here. You can see we have graphs, so it's not so clear for you, but we have graph and grid. So here you have results up to this date, 2011, 8th of July 2011. So you have results up to that date. Okay, but you don't have results here. So all these dates, no results yet. So that's it for this top menu. We have also this object panel here, the object the option panel. Here you see all different objects. For example, you can see the definition of your model. So this is typically what you have in the run spec section of E100 syntax, E100 model. You have the number of grids in the X, Y, and Z directions. Okay, as a matter from this, you have a total number of grid blocks, which is this, and out of this, 58,000 active grid blocks. So it's relatively small model, but it's fair enough. It's good because you can run pretty fast. As you can see, we already run simulation in just few seconds. We have some results. So, and some other options. So we have 15 wells in this model, okay, and a total of 831 connections. So this is this option panel. Okay, this option panel comes with a settings panel as well. So depending on what you select on this folder, any of these folders, you will see the setting will change accordingly. So for example, if you go to graphs, the setting changes accordingly. Okay, so if you come out of grid, you have different settings. And then we have this big window here, which is the visualization window. And you can see here you're visualizing a given property for, in our case, is pressure in 2 dimensions. You can also see it in 3 dimensions, right? And then you can also see the histogram. So that's for the visualization panel. For the visualization panel on the right-hand side, we also have some tools, some functionalities that visualization functionalities that allow you to easily analyze your results. For example, you have some cross section, you can create a cross section, okay, just to visualize given property here, okay, in 2D, 3D, all right. So everything is just available. And then the final part of this graphical user interface is the comment panel or comment log panel. Here you have so let me go back to the beginning. So here you have the report of everything that has occurred here, okay? So you remember at the beginning, by the way, let me just, okay, no need to go back. But at the beginning, when you initialize your model, okay, or let me do that, so sorry. So this button here, so yes, allows you to maybe reinitialize your model. In this case, you have several options. You can see that the simulation here is still, you can play to that time step and continue simulation from here. But here you can also clear the results and reload. But when you load the model like this, what you have is that when you initialize the model, you have the oil in place. So for example, here you have the original oil in place, which is 10.9, around 11 million standard cubic meters. So, and then a lot of other properties which I will not go into the details. So this, you have this in the comments log. You can also filter around, and sometimes you want to have a bigger visualization, so of your 2D or 3D property. You can just reduce this comment log. Okay, you can remove it, and whenever you need it, you bring it back, right? Just by selecting on this information log. All right. So for now, let's just keep it. So So here, this is it. We have seen all of this. Let's continue running the simulation, okay, from that time step. And let's look at this property in 3 dimensions. So here you also have in the grid properties. Now let's look at what we have here. You have these folders, okay, different properties. You have the initial properties. These are the properties you need. These are static properties actually. Okay, mainly your static model. So you see your porosity, your permeability in the X, Y, and Z direction, net to gross ratio, what you need to calculate hydrocarbon in place, and also the permeability. Static properties are all here. So you can visualize the porosity, for example. So you can see so here you have the palette, okay, that's displayed. You have the porosity that you can see, and then you can see the histogram of the porosity distribution as well, right? So this is a porosity distribution. You can see permeability, X, Y, and Z. You can also here inside this palette, you can also see a kind of histogram that is also showing you the distribution where you have high porosity values and so on. So you see here we have a layer. For example, in this thread, we have a layer that is, so we have few grid blocks with high permeability, and apparently they look like this red one we're seeing right here, okay? So this is, yeah, by the way, you can rotate this model just by clicking. So you left click and then you rotate it as you want, okay? It's up to you. If you want to zoom in and out, just scroll in and zoom. That's, yeah, it's scrolling and out, okay? So this is the way to zoom. And then if you want to move the model around, you just right click and then move around and move the model around, okay? And for example, you make a mistake, you're lost somewhere, you don't know what to do, how do I get back? And there's no need to waste time. You right and left click together and you come back to the default settings, all right? So these are just few things you can do around. You can sort of discussed all of this. So these are static properties. You can see also in this folder, you see the calculated properties. You know that when you're running simulation, the whole idea of simulation is for you to calculate the pressure and the saturation distribution at every time step, right? So you calculate the pressure. So these are calculated properties. You find them under calculated folder. Okay, pressure, saturation of oil, saturation of water, saturation of gas at every time step. And you see these are the properties that are changing with time, right? So all these properties are in the calculated folder. You also have a fluid in place folder. This is quite interesting. One interesting one here is the mobile oil in place. So maybe you want to make prediction. This can help you find out where do you have more mobile oil, so you can drill your if you will. All right. So it's quite an interesting property. Of course, you can calculate that by yourself using these user codes. You can create anything for you by yourself. You can recreate the properties you have here. Okay. Regions gives you the type of, so all the regions you have. You can have the fluid in place. Here we have 3 fluid in place regions. Okay, you have saturation, PVT, so let's say equilibration region. We have 2 equilibration region. We have 1 saturation region, so 1 rock type in the model. So meaning that you're just specifying single set of fluid variability curves and pressure curves in your model. So that's for the regions. And then you have the user codes and user maps, which will allow you to create your own property. I'll not go into that. So by default, you have 0, nothing is here, or you can create whatever you want to create. Right. Let me just display something. So here, once again, we're looking at 2 dimension. Let's continue this simulation. So one thing I did not really mention is you could have actually moved this time slider to the end without completing calculation, and you will see the wells will pop up depending on your development schedule. Remember, I told you in this model there are 15 wells. You can see well 34 just came in, was just brought in, okay, and then and so on. You see in red when you see the code. So red are production wells. Later on you'll see blue. Blue are injection wells. Okay. So that's that. Let's visualize some property in 2 dimensions. So yeah, another interesting thing that we have in To Tnavigator, a key functionality is, so in the settings of 3D window, this is unique to 3D window, you will find some streamlines. So streamlines, I can remove this grid, okay? So for me to remove that grid, I can just uncheck this show grid settings. Show grid, I see only the wells and the perforations. And then I want to select streamlines. Streamlines, so I see the streamlines from either producer to injector. So you can see well 1, which was red initially, the first well. Initially it was red, it has changed to blue, so it has been converted to an injection well. So now it's injecting water. And we can see the streamline. So the property we're looking at again is the pressure. We can look at other properties, and we can also play around. So you can see here saturation. We're looking at saturation. Here the saturation is oil saturation. This is this palette is displaying oil. You can see that the saturation here is lower, so meaning that you have some water. This is because you have an injection well here, and you can see the saturation is going to the other wells. So you can actually use these streamlines to qualitatively analyze your water flood performance in your field. Okay, so this is it for streamlines. You can also play with the settings. Oops. You can also play with the streamline settings. So this is actually how to access settings. You can see maybe unique, use unique well colors, for instance, and this will show unique well color for each well. And what did I do? I did apply. So you have to apply. I use unique. Apply. So okay. So you see, I see where this, which well is contributing to which injector is contributing to which producers and so on. See, for example, this well 48 is receiving a lot of injection from all of these. It's communicating with all of these wells, so it's getting seed injection from these 3 injectors as well. So anyways, this is it for the streamlines. These are mathematical abstraction that depend on what we call the streamline density. Okay, so this is really important when you have a water flood in your field. And these streamlines depend on this streamline density. So if you increase this density, you'll have fewer streamlines. Let's say 20. Okay, you have fewer streamlines. So the streamline itself can be calculated by imagining the rate, maybe the liquid rate divided by that streamline density. So the higher the streamline density, the fewer number of streamlines you will have. So we go back to the default, which is 5. And in this case, you will have a better analysis. Oops. So let's, so that's it for the streamline. It's really important when you're using this tool. So this is a unique To Tnavigator tool, the water flood analysis tool. This is computed based on these streamlines that have been computed here. Okay. So we may not have time to discuss what happens here, but you should just have that in mind. Okay, let's show the grid again and then continue. So you can see our simulation is complete. Please don't hesitate to ask questions. I don't know if there are some messages in the chat box. Yeah, I can see a lot of things. So anyways, let me not distract. If you have questions, you can ask it, or someone, or Benga, you can read it.
I'm tracking messages.
Okay.
No questions for now.
Okay, thank you. So here, what I will, let me see. Let me do something quickly. So let me take this time slider a little bit backward, and let's see, when this well 1 was converted to injector. The idea is we want to do this. Well 1 was converted to injector around here. So what I want to do, okay, is I want to kind of introduce some tracer, mathematical tracer in well 1. I want to trace, so this is when the well was, so after, in the next time step, okay, it's converted to an injector. So I want to trace the water, okay, and see when I have water breakthrough in other wells. So for me to do that, the whole idea is I just want to also show you another thing. So in To Tnavigator, if you want to add a well, it's quite simple. If you want to drill a well, you can just come here, add a well, right? And then you see this window. We will not do that right now. That's why I want to actually modify, edit a well. So I want to edit well 1. So this window pops up. And so this shows you, it gives you, it allows you, if you're, you see it's the same window as compared to when you want to add really new well in your field or reservoir. So you can select either connections or geometry, and you have all of this. You can select points, okay, and drill your well, maybe horizontal deviated, just by clicking in the model. Okay, I don't know if you have time. Sometime I can show you something like that. And what I want to do here is in the control. Okay, in the control, you can see the type of, so this is an injection well, so on, control mode. All right, now I want to add tracer. So tracer 1 so call it water 1. You can name it whatever you want to name it. All right. So Naleimolabh, for example, that's this tracer, and concentration should be 1. So let's save that. We can also add let's add a no need. It's fine. Let's continue. So now we can continue running simulation from this time step. Okay, so we run, and you see it has cleared the results. Oops. License. Okay. So in this case, I'm just going to open a recent. So okay. So this is a plane. This is the model we're looking at. Let me have a bigger visualization screen. and then we want to continue. Okay, no problem. So calculation is ongoing. Okay, you can follow the log. Sorry, you can also perform some filter. Now, we've injected tracer. So because we've injected tracer, we now have this new, in the grid properties, in the calculated result, we have this new ASP and tracer that pops up. Okay, it wasn't there initially. So you can see the tracer we created, lag 1, okay, concentration. We can visualize this. Now, you are not really seeing anything. Okay, mind you that the tracer concentration is quite really low. Okay, if you come here, you see, so here what we have is tracer, right? So one other thing, if the values of each grid block, you can see the values of each grid block right at the bottom. So if I click, you see as this is changing. Okay, if I come closer to the well, I'll see the values of the tracer, okay, the tracer concentration in this case. It's not really obvious how this water has moved, but you can also play with the local palettes. So here is because it's a linear scale. If we change that scale to a logarithmic scale, okay, local palette, logarithmic scale, okay. So we see, bring it to logarithmic scale, we begin to see the tracer moving away from the injection well. We begin to break through in well 22. The water front is still not yet at well 3. Okay, so this is it. You can also play around, as I told you. You can make a cross section just to visualize. So by selecting this, this is cross section. Okay, put your mouse there. You see, create a cross section. You can create a cross section. There are different cross sections that you can create. You can have a vertical cross section, which is, so you can just simply click between 2 points, right? And then you have this cross section that has been created. You can move the cross section as you want. You can rotate it, okay, by clicking at the edges of the cross section. So I'm making a cross section that's just cutting through well 1 well. So this is a vertical cross section. You can have it. You can have a coordinate plane, maybe a horizontal one, so in the Z plane. You can have point selection that allows you to select several points. Okay, make cross section. Oops, yeah. However you want to make it. All right. So I'll still come back to the vertical cross section and stay here. So you have well fence just to see the cross section across the well and so on. So when you close, To Tnavigator by default has already taken that cross section into account. So you can, for cross section, it's a 2D property. You can visualize it in 2D window. Of course, you can also see it here in this 3D window. You can also see it because so here you can use, so in the settings, cross section, you can use show cross section, okay, and then you can decide to cut from the front or from the back. So if you cut from the front, you see this is that cross section that we created. You can cut from the back as well, and then this is just the cross section you have created. But we don't really want to see this. So if you want to see that cross section you created in 2D window, you come to 2D, all right, 2D window. And very importantly, when you are in 2D window, so this is specific to 2D window once again. So you are in grid properties. So you have the settings for grid properties, but then in 2D and 3D window, the settings also changes. So in 2D, one important part to look at is here, this drop down here, you have a lot of tools. Okay, so for example, you have, so what we're looking at is the roof. This is the top of the reservoir, all right, the roof. You can look at other things like maybe the sum of this property. So this is sum of the concentration in this case. If it's any other property, it will change accordingly. This palette will change, pressure, saturation of oil, whatever it is, okay? So you can see the sum of that property for all the grid blocks in the vertical direction in the Z, the sum of all of them in the Z direction, okay? So that's what you will see, right here. And so you have a lot of functionalities. Okay, I won't go through all of them, but just to show you. And then at the bottom, you have cross section. So if you select, it's a cross section, and this is what we have. Okay, so you have that cross section which we created passing through these wells. Why is the well name not showing? Okay, it's not a problem. You just see well names, and then you see we had well 1, cutting through well 1, well 50. So this is just a vertical cross-section. Maybe we did not cut through the other well properly. Okay, so here, let's maybe go back to our tracer we were looking at. So you see the time slider is at the end. So this is the end of simulation. This is 2015. You can move this backwards just to see, okay? So here, I'm not looking at well, so let me pass through well. There's my cross section. See cross section. Let me use the point selection, okay? So let me use the point selection to make my cross section. So I'm going to pass through well 50. I want to pass through well 50 to well 1. Oops. To well 1, maybe to well 3, and then somewhere else. So close, and then we go back to 2D window to see that cross section for tracer concentration once again. And then we're here. So this is well 3. You can see well 3 now. You can also add grid lines if you want. Grid lines, okay. Something like this. And then you can move your time slider to see when did we observe water breakthrough in well 3. So you see, at this time in 2013, or thereabouts, we begin to have water breakthrough in well 3. And so on. So from these layers as well. So this is where water is mainly moving, and then you can see the evolution of this water front in this cross section. Another interesting thing that we have in this 2D window is what we call the bubble map. Okay, so the bubble map here, it shows you, although yeah, you have to need some settings. Here, for example, you can see so it's just showing a lot of things. We don't need all of that. Maybe let's clean it a little bit. Bubble map, okay. So these settings, here we just want, maybe I should remove all of this. What do I have? So you can see the bubble map. So what I have here now is mainly showing. But then you can see the bigger the bubble, the more the production. So in this case, cumulative production. Okay. Let me make, so you can play around the settings. So these are the settings. I don't want to spend much time on things like that. Okay. But then you can play around the settings, have what you want to, which color you want for oil rate, liquid rate, water rate, etc. You can modify all of that. So that's it for, and you can also look at it. Why not? We're looking at the cross section. You can look at it from the roof, or roof is right here. So you can also see the bubbles. One interesting thing you can look at is, okay, so directly, let's, I'll come back maybe. So from this bubble, directly, I can click on this well 27, right? And I see, I come to graph. Okay, you see what happened there. What actually happened is I moved from grid to graphs. So by selecting the well to the map, okay, I move from the grid to the graphs, or you can come manually, so from grid to graphs. And what we're looking at here is the rates. So you have different properties, different parameters you can select from here under the graph folder. And also you can select, is it for the field you want to see the oil rates, or for the wells, or for setting connection. Okay, so the group here is field. So you have the production rate for the field. And one thing you can clearly see from this window, this graphical window, is that we have, here we have it on display, the oil rate in red, and we have, so here you have, when you select rates, see the settings, okay, for the graphs. You see all the rates you have to select. Is it oil rate you want? You can unselect all of them and select what you want for yourself. And you can see here we have oil rates calculated and oil rate with H, which is historic. So this is the historic oil rates. And when you put your mouse there, you can actually see the value, okay, at every time step. And this is the calculated oil rate. So this by default, you see, quickly you see that this model is not matching, and it's a history matching model, first of all, and it's not properly matching. terms of oil rate. You can also go to water rate and the historic water rate. You can display this, okay? And this is what you have, but this is for the group. And then you can go on to analyze well by well, all right? You see well one, you remember what happened to well one. Well one was initially a producer when we had grid properties. Now it's blue. Let's go to 3D. So let's visualize another property, maybe. So you see well one right here, it's blue. Initially it was red. So it was initially a producer. So you can see it produced. And then it stopped production because it has been converted to an injector. So why don't we maybe include water injection rates? Perhaps we could see that water injection rate, where is that? So water injection rate, this. So you see from this date, well one started injecting water, okay? And you can see with it, okay, with the historic. So just this one is just to show. So and then you can also go on further to analyze the, why am I not seeing? Okay. So you can go on further to analyze to look at the production rate, even at the level of the completion. So you see here, or even here, I think it's the same thing. So you see the completion. So well, one has been perforated from layer one. So this is IJK, okay? Or yeah, so this is, it has been perforated from layer one down onto, so these are all the perforations of well one. We can also see that in the 3D grid window. If I remove this grid, so remember, so I want to remove that grid, where so grid, okay, so here, I remove that grid, this is well one. I can look at, see, all these connections for well one, okay, that are in model. So once again, I right click and left click together, you come back to the default settings. So maybe I should keep back my grid. Okay, so you can visualize the results even up to the level of the connections. You can see so what's the production at each connection, and you can tell which connections are producing more. So when you're performing maybe field development and you want to decide on your perforation intervals, when you run your simulation, you can even come to the level of the completion to see which completions are producing better and which ones should I leave instead of and if you're also producing water at some stage, which completions are producing more water, perhaps you may need to perform some workover on those completions. Okay, so this is how so you can visualize this. So all the wells, you can just go like that and see the results of all the wells. So you see some wells are not so badly matching, like this well, for instance, 34, but this is simply because it's at the beginning, you know. If you see other wells, we're matching also at the beginning, and then later on they started mismatch. So we have limited time, so I don't think we'll play around trying to match that. So this is it for the graphical, and then you can see other properties. What about total? You can see the oil total, the liquid. Why not liquid? Why is liquid? And let me show you something about liquid. So liquid rates and historic. You see, if I take off everything and just show the liquid rate and the historic, here, what you can see is that they are both completely matching. Why is that so? It's simply because the control for this well, or for the historical control mode for the production wells, is liquid rate. Interestingly, for the wells also, at the bottom we have a bar that is showing you the status of the well and the control mode. So you can see this brown line, what's showing you is that the control mode is constant surface liquid volume. So this is LRAT if you use the keywords of E1 syntaxes. You can also access your schedule right here, okay? The schedule section, you can access it right here, and you can see the control, the production control, and you can see in WConHist, the control mode is liquid rate. That's why you see, so what the simulator is doing is it's forcing the model to reproduce the liquid rate and then calculate the oil and the water rate. That is why you see that it's not matching in terms of oil and water. What you have in terms of oil and water, it's not matching, but liquid is 100% matching. That's simply because you have that control mode. And it's the same for all the wells, okay? The production wells, they are all matching in terms of liquid rates. All right, so field-wise also, you see that this model is not, we've seen that already, it's not matching in terms of, so we can look at total production and all the properties you want to select. Okay, you have them here, not going into all of these details. In pressure, So depending on what you select, if you're in group, you can only visualize the reservoir pressure, because for the field you have reservoir pressure. But if you go to the wells, what you can see is the bottom hole pressures for the wells. All right. So if you select pressure wells, you will see all the bottom hole pressure, tubing head pressure, and etc. etc. But if you select group or reservoir, this is your average reservoir pressure. And also, if you select a given well, you can see a lot of properties like the equivalent pressure on equivalent radius. I believe you'll be they will tell you about that. Okay, so you can use either this or BP9. So BP0 is well block pressure. So the pressure in a given well block. So here is the 4 blocks around the well. Here is 5 blocks around the well, and this is 9 blocks around the well. So these WBP9, okay, sometimes you can approximate it to be equal to your, so when you're performing some analysis, you can approximate it to be your average reservoir pressure within the drainage radius of the well, right, or average reservoir pressure. But then be careful, it's the average pressure for 9 blocks, okay, at the nine blocks around the well completion. Okay, so these are just a lot of properties you can access. This is how you can access all the things. For analytics, you can have all the ratios: water oil ratio, water cut, gas oil ratio. This is, you find all of that in the analytics. So we can see the GOR for the field. Okay, once again, we come to the field. You can visualize maybe the water cut. Sorry, where am I? Analytics. Okay. So ratios, you have ratios and so on, different things, number of wells, productivity index, okay? You can see all of that here. So you have the gas oil ratio if you want to see that. You have the oil water cut if you want to see that, etc. etc. You have a lot of other tools, very interesting tools that you can use here. Also, for example, you have the well section tool. This allows you to create maybe so the well profile. You see the well profile. Let's select well 1, for example. So you select well 1, maybe well 22, and any other well. So we have these 3 wells, okay? We can select anything, for example, maybe the oil rate, okay? You can see, so you see the oil rate, and this changes. So you see when you move the time slider, you can see how the oil rate changes. Remember, see well 1 in this case, remember well 1 was initially a producer before it was converted to, so it's producing, and at some point, you see, so here the values are just in 0, okay? It's already an injector. So this oil rate, and you can also maybe compare oil rates with the historic oil rate, and you can see which layers, okay, which perforations. In fact, so you see these are kind of the grid blocks in the model from your wells, okay, the well penetrating, the grid blocks penetrated by the wells. This is what you have. You can, I think you should be able to display grid blocks. Okay, so I have in this, to add grid scale, okay? So these are the grid, you see is in line with what you have here, okay? And so you have the historic and the calculated oil rates. You can also add these tracks together just to have them together in a single track. Okay, have another meeting. That's so you can see the differences, okay, between here, we don't have much difference. Remember that at the beginning, the model is better matching and so on. For the well 1, we didn't really have much issues, but look at well 22, for example, okay, and then you can see at some point you may have some discrepancies in this. Let me look for another model that is matching. Another well rather, not model. So let me remove this grid scale so that okay, so delete that. So you have this wells, and you can see well 3. You can see the significant difference between. So you can see which layers are not even properly matching. You can go even up to these details. Okay, analysis. You can also include maybe your perforation. Why not? So you see the perforation where the well has been perforated. And you can also see the events if it changes with time. If at some point in time the perforations have been short, you will see it that to be short at that time. And then okay. So this is it. So you have a lot of interesting tools here. User. So we are not going to. Another nice tool here is the history versus calculator. So it's for your history matching, right? This shows you how you're performing in terms of history matching. So you can see on the vertical axis you have the historical um, calculated parameter. So be careful here. We're looking at oil rate, okay, and then for wells, so you can actually look at it at the field level also. So at the field level, we can see how the history versus calculated results for oil rates. And then here in green, this green bisector here is 45 degrees, of course. So meaning whatever you have here is perfectly matched in history is equal to calculated. But if you have something above, it means that history is more than calculated. If you have something below, it means that calculated is more than historic parameter. So here you will see for the field how you are performing, okay? So, but then let's look at it at the level of the wells. So at the level of the wells, okay, so you see at the beginning, you have, what am I looking at? Oil rates. And then here you also have the deviation. So these two additional red bisectors, okay, is showing you 10% away from the perfect match. So this is a case where you've decided that, okay, at 10% deviation, your model is pretty much matching very well. So it's okay, it's an acceptable match for you, then 10% is okay. Well, what you can also do is now you can say, okay, let's say for my high rates wells, let's the deviation be 5%. So you reduce that because your high producing wells, you want to have maybe a better match around that, okay? So that your prediction will be more accurate. So you can make all of these settings and then you can move this around. When you move it around, what you see is, you see at the beginning, you see these wells are, this wells, so well 1, 24, these are the wells existing at this time, 31 actually, they're all matching properly, perfectly well, almost at the beginning, okay? And then you see they're matching pretty well. Okay, what are we looking at? Why is it matching this well? No. Okay, so you see at later time, see what's happening. Some wells begin to deviate, right? So you have some wells that are still matching. Okay, so you can see, so you see well 3, 31, you see, so look at it, well 3, 31, 22, 35 are mismatching. Okay, you see all of them, and then additional wells that are mismatching. Well, in this case, so we begin to see also other set of wells that are so high rate wells. So remember we specified 5% and 10% for high rate well. This box here takes this box shows us, so you see the rate, medium rate, and so when it's above this, it should be high rate. So this box defines that range, okay, of medium rate, and then above that is high rate. So we can look at the high rate whereas 48, 33, 27, and so on. So we can even create a well filter, okay, maybe a well filter, just to filter these wells. Let's create a well filter and select all. So oops, select all. I want to select 48, 33, 27, 40. So 48, 40, 33, 48. Let me leave this ones. And there was another one, maybe 7, I can't remember. So, okay. So we select this, and so we've created a well filter. Okay, these wells are not matching. We may want to investigate. Of course, there are also other wells here, medium rate, but we're more interested in this. We may want to also investigate where are these wells located. So we can come back to our grid properties, maybe in 3 dimension, and see, because we have our well filter on, these are those wells, okay, that are not matching. For these wells, these ones on this side, you can see regionally maybe some kind of so Regionally, you can see it may be some kind of property in this region. You can decide to modify a given property that is uncertain based on your studies. So it may be permeability, all right? Or you may be tempted, or you may also see from the graphs that mainly what's not matching is the oil rate and the water rate we're looking at. And this quickly, you may want to start thinking of playing with your relative permeabilities in order to, in this case, you see you have water that is arriving later, sorry, water that is arriving earlier than the historic, the measured one in the field. The model is giving us earlier water arrival, so we may want to delay, slow down the water in, so we're looking at the field, in the field, okay? And then we may also go well by well to see which, so this one for oil, so yeah, so well by well to see how they are behaving, okay? So here you see the water is also arriving earlier than these other wells, etc. So globally, we want to modify some properties around that region, okay? So you can quickly create a new property here. But mind you, we are working in the simulation window. If you're working in the model designer window, so here, model designer, it will allow you to quickly create new property and create a new simulation run, a new development scenario, strategy, whatever you want to do. Okay, it gives you more flexibility and you can perform almost everything you have here except the water flood option that is not existing in the model designer. Okay. So, I've showed you how to create a well filter. We can also remove the filter. Okay. So let me just select all that.
Yeah. Hello, James. Yeah. Hello, James.